Hello, Math Studies students, and welcome to your online lesson. Today we'll be talking about linear functions. Specifically, we'll be interpreting them and solving story problems with linear functions. Our goal is to be able to efficiently solve these problems. Linear problems, or linear functions, sometimes called linear models, are functions that create a line when graphed. And we've been looking at linear functions or linear equations since middle school, covering it pretty in depth, certainly during freshman algebra as well as geometry. We often look at a linear function in this form, f of x equals ax plus b, also known as y equals mx plus b, where this a term is our slope, the coefficient of x is our slope, and then the b is our y-intercept. And so for a word problem, the slope is going to be a rate. It's a change. Perhaps it's a cost that you're getting over a certain amount of time, or for a certain number of sales, or a certain amount of things that you're able to do in a certain amount of time, or something like that. But it's some sort of rate that's going up as x increases, or is affecting your total that would be going up as x increases. And then the b is usually like a flat rate. It's an initial value, and initial means starting. And so if I plug in 0 for x, I'm just left with this initial value, or this starting condition. And again, that's achieved whenever you plug in a 0 for x. And so this is all review. But again, linear equations, if we want to find our initial value, we plug in 0 for x, and we have our a, or our m, which is our slope, always multiplied by x, also our rate, and then our b, which is our y-intercept or initial value. So let's take a look at an actual example. This problem involves playing tennis. So the cost of hiring a tennis court for h hours is given by the formula C of h is equal to 5h plus $8. Find the cost of hiring the tennis court for 4 hours and then 10 hours. So first let's look at our function here. So our function c, or c of h, tells us that our input, the thing going into it, is our h, and h represented the number of hours. And then we're going to get our total cost. So if I write down the original function, c of h is equal to 5h plus 8, what I'm going to do now is replace my h, my number of hours, with 4. So I've got c of 4. Now what does that represent? I've put in a specific number of hours, which is 4, so this should represent the cost of playing tennis for 4 hours. And again, I'm going to replace the h here as well, put a 4 there, plus 8. So the exact same value went in for both h's, one of which is just a label. That's the one on the left here, c of 4. Again, the cost of 4 hours, and that's equal to 20 plus 8. So c of 4 equals 28. So what does this all mean? The cost of playing 4 hours of tennis is $28. And since it's a word problem, we could put a label on that because this is money. But we have an ordered pair, an input of 4, an output of 28. Let's do this one more time. Now we're going to do it for 10 hours. So again, I'm going to write down my original function. C of h is equal to 5h plus 8. That hasn't changed, but now what's going to change is the value that I'm plugging in. So I have the cost now of 10 hours of tennis. My input is 10. 5 times 10 plus 8. So I'm going to end up with 50 plus 8, or the cost of 10 hours of tennis is $58. Now, what's the common mistake that people are going to do? They are going to just leave c of h, and so they'll have a final answer of c of h equals $58, which defeats the whole point of function notation, because it's not telling you what the input is, plus it's not even mathematically accurate. C of h does not equal 58. C of h is the original function, 5h plus 8. So don't do that. Make sure that we are inputting so that when we get to the end, we can see what both our input and our output was. So that was a pretty basic example, just plugging in values. Now we're going to do something a little more complicated. This time we don't have a function actually written, so we're going to use a table to help us write a function. A taxi service charges $3.30 for stopping to pick up a passenger, and then $1.75 for each kilometer of the journey. Just to point out here, This is a European spelling of kilometer. IB will often use that on their IB exams and things like that. So it's not a misprint, it's just an alternate spelling. And we're going to complete this table and then eventually find the function c of d and calculate the cost of a 9.4 kilometer journey. So we're starting off with our initial value. This is the cost before we've traveled at all. We get into the taxi and already we're going to pay a cost because there is a flat fee. And that flat fee is $3.30. That's just for stopping. So $3.30 is our initial cost by plugging 0 in for our input, which was D in this case. Now, if I go 2 kilometers, I need to add on my initial cost, which I'm starting with $3.30, plus the 1.75 plus another 1.75 because I'm going 2 kilometers. And so then I'm going to end up at $6.80. And then if I repeat that again, where I take my initial cost, the $3.30, I do 2 175s and then 2 more 175s. So I'm adding up $3.30 plus 1.75 plus 1.75 plus 1.75 plus 1.75. Again, 4 1.75s, one for each kilometer that we're traveling. I end up with $10.30. And so we can keep doing that, but really what we're having is a pattern here. Since we're going by 2s, each one of these values, I can just take my previous value and add on 2 more 175s, or if I take 175 plus 175, I end up with $3.50. And so really that's all I need to do to add on here. So if I add on $3.50 here, I end up with $13.80. And then I can rinse and repeat and do that for the last 2 as well. So I've got all my values filled in. And now what we want to do is we want to find our function. Now some of us might already kind of see what the function is before we do anything else, but I'm just going to do a really quick rough sketch of this graph. I'm really only dealing with positives here. And we notice that when my x is 0, or in this case my d, which would be like my x-axis, and then I have my cost axis right here, that when I plug in 0, I have already a value of $3.30. So that's essentially my y-intercept, but it's also my initial value. And then what's happening for every value, every kilometer, I'm moving up at a rate of $1.75. So I'd be jumping up 175 and then another 175 and another 175 and so on and so forth. And so we end up with this nice linear graph like that. And again, we can see that our y-intercept, when our input of D is 0, we end up with $3.30 because that's our initial cost, our flat cost, something along those lines. So I'm going to attempt to write my function now. So I will write C of D, cost based on an input of a certain distance, is equal to, well, for every D I have, how much am I getting charged? Well, I'm getting charged $1.75 for every D. And again, D is getting measured in kilometers. So for every kilometer, I'm getting charged $1.75 plus a flat rate of $3.30. So you can see now if I plug in 0 for D, I would end up with 1.75 times 0 plus my $3.30. But this would cancel out, leaving just my initial cost of $3.30. Well, what we're being asked for now is 9.4 kilometer journey. So I want the cost of traveling 9.4 kilometers, which would be equal to 1.75 times 9.4 plus 330. Now for this, since there's just a couple decimals involved, I'm just going to put this all into a calculator. Now I'm not going to put this in the calculator. That's just a label. That's saying that the cost of 9.4 kilometers of travel in this taxi is equal to all of this stuff. So I'm just simplifying. And notice there's no variables anywhere here, so I'm not going to use y equals on my calculator or anything like that. I'm just going to punch it in to calculate 1.75 times 9.4 plus 3.3. And I end up with a final cost of $19.75. So that's the cost of traveling 9.4 kilometers. So my input, my distance traveled 9.4 kilometers, and my output, my cost, $19.75. Our last problem here, for example 3, involves really two different things that are going on. Tennis balls are sold in packs of 3 for $11 per pack. And then the balls cost $2.40 each to produce. So with a factory running cost of $1,750 per day. So we want to find the cost and revenue functions in terms of N balls per day, and then eventually determine the break-even production level. So let's start by writing our two functions. And again, we want to find a cost function, and then we're also going to find a revenue function. So cost is the amount of money that we're spending. Revenue is the amount of money that's coming in. And we want both of these in terms of N balls, so the number of balls. So in terms of means that is what is going into our problem, or we're going to have N's in our functions. Essentially, those are our inputs for both of our functions. So let's start with the cost one. Well, what information do we have about costs? Well, we know they each are $2.40 to produce. So each ball, and again, we're representing the number of balls with an N. So if I were to do a cost function like C of N, the cost of a certain number of balls, that would be equal to $2.40 for every single tennis ball that's being produced. So 240 times N. Plus, there's this flat rate or initial cost of $1,750. And again, you can see that even if I didn't plug in any value for, or plugged in a 0 essentially for N, where the 240 N canceled out, I would still be left with this cost of $1,750. That's my flat cost. All right, and now we're going to go ahead and do our revenue function. So our money that we're making, so the revenue based on a certain number of balls. Well, we know that we can sell the balls in packs of 11. But we're not getting $11 for each ball. We're getting $11 per every 3 balls. Or if we take that $11 and divide it by 3, that is equal to the cost of a single ball. So I don't want to write this as a decimal. I'm just going to leave it as a nice little fraction there, 11/3. And so those are my two functions. Now what I want to do is I want to determine the break-even production level. And what that means is that the amount of money going out, the cost, is the same as the amount of money coming in, the revenue. So what we can do is we can say that, again, this is really just a glorified label, C of N. So my cost is all of this stuff. And I want to find out when all of that stuff is equal to this right here. Whoop, and I made a mistake earlier. So that was 11/3. So that's the cost I get for a single ball. And I want to multiply that by N for the number of balls being sold. So again, it's not $11 for each ball. It's 11/3, or 11 divided by 3 times N for each and every single ball that we have. And let me just show, for example, quick here. If I had 3 balls being sold, that would be 11/3 times 3. And since we're dividing by a 3 and multiplying by a 3, that would cancel out. So if I sell 3 balls, I get $11, which checks out. That was the value that we had for a pack. So now what we're going to do is we're going to take our two functions. And again, I was saying that we have glorified labels here. We have our cost, and then we have our revenue. And they're both equal to the right-hand side of these equations. So what we're going to do is we're going to set those right-hand sides equal to each other. So I have 2.40N plus 1,750. For every tennis ball sold, this expression is equal to the cost. And I want the cost to be equal to 11/3N, which is the amount that we're getting in for tennis balls sold. First step I'd like to do is get all my N's to one side and all of my non-N's to one side. Since I already have N's up on the right and there's also some N's on the left, I'm going to subtract the 2.40N from both sides. That'll get rid of all of these N's, leaving me with 1,750 equal to 11/3 N minus 2.40N. And in order to combine these, what I'm going to do is I'm going to go to my calculator and combine like terms. 11/3 minus 2.4. So in order to get the fraction in the calculator, I'm going to put a parenthesis and then do 11 divided by 3. So that essentially represents my fraction. There's other ways to do that too, but that's the easiest for me. And then I'm going to subtract the 2.40. And I end up with this ugly decimal where it's 1.26 repeating, eventually gets rounded to a 7 there at the end. But what I'm going to do now is a great shortcut, and take notes on this. We're going to press Math, Enter, Enter, and it turns it into a fraction. And that fraction is 19/15, which I will now use to finish off my problem. So I combined my like terms, and I ended up with 19/15 n is equal to 1,750. And now, to get rid of the 19/15, I essentially have to divide by that because it's multiplying n. And how do we divide a fraction? We multiply both sides by the reciprocal. So 15/19. And so what will happen is the 19 over 15 and the 15 over 19 will cancel out, but I have to do that to the other side as well. And we end up with an n value of approximately 1,381.5, and then there's a 7, and on and on and on. So I'm just going to put dot, dot, dot. Now, I can't sell 0.57 tennis balls, so I would need to round up to the next largest number of balls to make sure I'm selling enough. And so I'd have 1,382 tennis balls. And now you might say, I might even need to round up to 1,383 because they are sold in packs of 3, and that would be the least number of balls to sell a complete number of packs. But that's the idea. All right, until next time.